I think this section is longer than I thought. Plus, I went ahead and made it 2 days on Thursday and Friday because there's no way all of this, you could retain all of this with just 1 day. So that helps a little bit, even though I had section 10.1 was supposed to be on Thursday. No, my videos aren't being made, so I'll have to try later. So back to the distribution of capital X bar. This, again, here's what capital X bar looks like. And little x bar could be anywhere in here. So now imagine little x bar is taken out here and I form a 95%er. I go out in both directions and I mean, you're probably wondering how I'm measuring 95%, but I did draw this graph and I know this is about the length right there. So imagine, again, that's about the length here. I'm not going to capture mu in this picture. And so what's happening is, I mean, the probability that x bar is going to be between here and here when you grab it, there's a 95% chance. And that's why we say this is a 95% confidence interval. There's a 95% chance I'm going to get a value that's within about 2 standard deviations. And I'm using 1.96 because that's a little bit more accurate. If you go to your normal table, which I don't think I have up right now, but if you go to your normal table and look down your list, 1 and then 1.9 and go to 0.06, you'll see that this leaves 0.025 area in the tail. So I mean, in general, if we're being a little bit lax about it, this is about 2 standard deviations in both directions. And but we still haven't learned how to construct it. Again, it's still the idea, but at least now we know that little x bar is in the center, and then we're going to go out so many standard deviations in both directions. So let's go ahead and compute one then. Remember, the standard deviation for this sample was 0.01. I mean, for this population was 0.1. So we start in the middle, which is x bar, so that is x bar, which is 12.05. And then I'm going to go left and right by so many standard deviations. And because I want a 95% confidence interval, that corresponds to approximately 2 standard deviations in both directions. Sorry about that. The visitor at the door, so you got to hear dogs. Okay, we got the mean, right? That's the center of your confidence interval. And then we go out so many standard deviations in both directions. And I did pull this up while I was waiting for dogs to be quiet. Let's see, here it is. You can see here, I want 0.025 in the tail of a 95% confidence interval. So 0.025, you can see is right here. So that's negative 1.96. That's why I'm using that instead of 2 standard deviations. This leaves 2.5% and a tail, and I want two-sided, so 2.5% will leave 95% in the center. So let's go back to this one. So that's what I'm saying here. You can see if you think about this, this is 0.025 and that's 1.96. So I'm going to go out 1.96 standard deviations. And then what's a standard deviation? Now this is the standard deviation for x, but I want the standard deviation for x bar because that's the graph, right? I'm drawing as the x bar graph. So this is 0.1 divided by square root of 100, and this is 0.1 divided by square root of 100. And so then I get my interval, subtract, get the left end, add, get the right end, and looks like I already did it down here. Here's my interval then. So this should come out to be 12.0304, 12.0696. And I am 95% certain that this contains the true mean mu amount of cereal in all the boxes made that day. So that's what this is saying. Yeah. So again, 95% of the time, if I use this method, I'm going to capture the true mean mu. Sometimes I'm not going to. A 90% confidence interval, this is a true or false, 90% confidence for the mean diameter of steel rods is computed to be this. The probability that mu is in the interval after it is constructed above is 90%. Well, after the interval is constructed, either mu is in there, mu is not in there. So this is a kind of a trick question. The probability that mu is in the interval after it's constructed is either 0 or 1. Before you construct the confidence interval, you have a 90% chance your interval will capture mu, but after it's made, it's a sure thing, and either it did or it didn't. So this is kind of a trick question. And here's another true or false. So hopefully you can tell the difference between these two. I'll give you a minute to think about it, and my next video I'll give you the answer. A 90% confidence interval is this. Which one of these statements is true? One of them is true and one of them is false. Okay, I'll be back soon.